Hello students, and welcome to lesson 1 of MAT 143, where we will be exploring a topic of percents. I am super excited to teach percents because I think that this is a topic that honestly has applications to everyday life. It's things that we always deal with, and we think about just things in percents. When I think about something being on sale and it's 30% off, I can begin to think about what that does to the price. Or when I think about something that's 50% off, I start to think, okay, I'm getting a good deal. I'm getting this half off. So I think that this is definitely a topic that has a lot of applications. That's definitely something that's important to all of us. And in this section, we're really going to talk about what percents mean, how you can use them, and even sometimes how they're abused in our news and our media and different outlets. So going on to the idea of percents, what does it actually mean? When I think about a percent, it directly means per 100. It actually comes from a Latin word, percentum, which translates to the number 100. So I have this little image over here that you see on your right, and it has all these little squares, and it actually is 100 squares, and it shows you where the number 1 is at the top and then 100 in the bottom right corner. And we start to color, well, there's 100 of those, so we start to color the number of boxes we want based off of what percentage we're trying to show. So whenever we talk about 1%, if I'm literally thinking about, okay, just 1%, let's write that, 1%, we are talking about 1 out of 100. So that directly is equivalent or equal to the fraction 1 over 100. So we quickly notice that there is a relationship between percentages as well as fractions. So if I go down here to this next slide and I look at these images, I see that I have 5 rows with 10 blocks each across. So that ends up being 50 blocks that are shaded. So I am dealing with 50 blocks out of 100, which corresponds to 50%. So it's very easy for me to write things in terms of a fraction and write them in terms of a percent. When I look at the second image, I have 25 boxes shaded. So I would say, okay, I have 25 out of 100, and that is equivalent to 25%. The interesting thing about this is that all of these can be simplified, right? So for example, I'll look at just this particular 25 over 100, but I certainly can reduce that fraction. I'm doing that here in orange, and I would bring that down to 1/4. Right? So I can think about this in different equivalent fraction types, or I can think about it as a percent. So we can't have percents without talking about this idea of being out of 100. Sometimes we want to know a percentage of something, but maybe we're not looking at 100 different things or 100 different items. So for example, let's pretend we have 30 people in our class. How many people make up 100%, right? So I don't have 100 people. I only have 30 people, but I want to know, okay, well, how many people make up 100% of my class? Well, if there's only 30 people in the class and I say, okay, I got 30 people, that's 100% of the class. So thinking about like from a professor's stance, when I do attendance, I say, okay, well, I had 100% attendance when everybody was there, right? So in that case, it'd be all 30 people were present. So we can think about values of percentages even though maybe the number we're dealing with isn't 100. So same scenario, how many people would make up 50%, right? So I'm dealing with 50%. It's not 50 people. 50% means literally half. So if I have 30 people in my class originally, so let's go ahead and write this down here. I had 30 people, and I want to know what is half of that. Obviously, it's probably really easy to say, okay, half of 30 is 15, because 15 plus 15 equals 30. But let's come up with a more formal way to find this value. I like to use this process called blank percent of blank is blank. This little statement you can use for every single problem that you go and do. And you're going to then fill in the blanks. So what percentage am I looking for? I'm looking for 50% of how many? So what is my total amount? Well, in this case, it's of 30. And what is it? Well, that's my unknown. I'm going to call that X, right? That's the thing that I'm looking for. So when I am going to actually go to solve this, I'm going to do this in green. We always put our percentage value over 100 is equal to my is value over my of value. And so I'm going to go fill that in, and I have 50% out of 100 is equal to my is what I'm looking for, and my of is 30. And then I'm going to actually go and solve this. In order to solve this, I'm going to do 50 times 30, and then I'm going to divide by 100. So again, I'm cross multiplying. I'm doing 50 times 30. So that ends up giving me 1,500. And then I'm going to divide by 100. The reason that I'm dividing by 100 is because I'm cross multiplying the 100 and the x as well. And so on the other side, I end up getting 100x. But in order to get the x by itself, I need to divide by 100. When I divide by 100, that leaves me with just x. But if I divide by 100 on one side, I have to do that to the other side as well. And 1,500 divided by 100 is just 15. So that's my 50% of 30 is 15, which is the original answer that we stated when we thought about this in our head. So it's easy to do this in our head when we're dealing with numbers that are a lot smaller, but it can get a little more challenging when you're dealing with bigger numbers that maybe aren't as familiar. It can also get more challenging when I think about questions like the second one. How many people make up 5%? That's a little more challenging to think about, right? 5%, that's not a nice even. I can't just cut it in half. I got to do a little more thought process here. So I'm going to make my statement again. Blank percent of blank is blank. And then I'm going to fill my blanks in. So I am looking for 5% of how many total people, 30, is what? That's what I'm looking for. And so I'm going to go ahead and fill that into my fraction. I'm dealing with 5% over 100, so 5 out of 100 is equal to how many over the total amount, which is 30. So again, I'm going to go and cross multiply. So I'm going to do my 5 times my 30. So when I multiply 5 times 30, I end up getting 150. Is equal to, I'm going to cross multiply the other side, x times 100, and that gives me 100x. And then in order to get my x by itself, I'm going to divide by 100, and that leaves me with just x. I got to divide the other side by 100, so when I take 150 and I divide that by 100, it gets me the value 1.5. So 5% of 30 people is 1.5, which is a little weird, right? Like if I was thinking about this in an application sense and I wanted to say, okay, how many people make up 5%? You can't have half a person. I can't have 1.5 of a person. It just doesn't make sense, right? So a lot of times if we were doing an application problem, we would maybe we would probably round it up. It honestly depends on the context of the particular problem, but I'd probably go ahead and round and say, okay, 2 people, right? But again, it definitely would depend on the context of the exact problem. But in this context, we are just looking for a value. So you would go ahead and provide your exact answer, which is 1.5. So one thing that we can do is we can convert from percents to fractions. So a percent can be converted to a fraction by dropping the percent sign and using the percent number as the numerator of a fraction whose denominator is going to be 100. And that makes sense, right? Because we're dealing with things out of 100, we'll have some type of fraction, and then we certainly, we can reduce that down. So just to give you an idea, and I think this is probably pretty self-explanatory, but let's say I'm dealing with 50%, right? So what this is saying is if I want to convert it to a fraction, I'm going to drop my percent sign. So I'm looking at a 50, and the percent is telling me out of 100. So these are equivalent forms, and we've pretty much already talked about that. Even if I'm dealing with a weird value that's not as, popular for us to see, like 32%, it'd be the same idea. I'm dropping the percent sign and saying I'm looking at 32 out of 100. So super, super easy to convert from percents to fractions. You do want to make sure that you always reduce your fraction values. So it makes your life a lot easier. It helps you to really think through the problems that you're looking at. So for example, if I'm looking at 50% and we just stated that that's equivalent to 50 out of 100, it is wise for me to actually reduce that down. And when I do, I end up getting 1/2. And this is actually a fraction that has a lot more meaning to us, right? If I were to tell you, oh, I want 50 out of 100 slices of your pizza, you're going to look at me like I'm crazy. But if I tell you, okay, I want half of the slices of that entire pizza, you have a better idea of what I'm saying, right? You begin to imagine, okay, let me take this entire round pizza, cut it in half, and that's how much she wants. So when we reduce fractions, they become a little more meaningful to us because they're values that we can start to actually visualize and think about in our minds. A percent can also be expressed as a decimal. So we've talked about, this idea of a percent can be written as a fraction, and we've learned in previous math classes that when you have a fraction, you can write it as a decimal, which means I could jump straight from going to a percentage to a decimal. So this idea that percents, decimals, fractions, ratios, they're all equivalent. They're all the same. They all go together. So in this particular example, I have my pizza, and I'm talking about that half. I can write it as 50%. I can write it as a fraction. I'm actually going to write this as 50 over 100. And then when I simplify that, it gets me down to 1/2. But I can also write it as a decimal. Okay, so super important. So how do I actually get to the decimal? How do I start with a percent and then convert it to a decimal? Well, in order to convert from a percent to a decimal, you drop the percent sign and move the decimal 2 places to the left. So let's start out with a value like 47%. When you're dealing with 47%, this is a whole number, meaning it doesn't have any decimals. It's a number that's, larger than 0. So you're dealing with a nice, pretty whole number. So in order to convert this, I'm going to drop the percentage sign, and I'm going to take the decimal. And because this is a whole number value, my decimal is on the end, right? Because it's 47.0. We don't ever write the 0.0 because it doesn't really mean anything. But I'm going to move it 2 places, 1, 2, I'm going to draw a little arrow here and put a little period, to the left, so that this entire 47% is the same thing as 0.47. Okay, let's do another one. Let's say I have 39%. So I'm going to drop the percent, so that's 39. And I know that my decimal is at the end because this is a whole number value, and I'm going to move it 1, 2 places. I'm going to put my decimal there, and so I'm left with 0.39. Now notice how I'm making my decimal point like very obvious. It's a clear dot that's large. I would say bolded. Like you can tell where my decimal is. I expect you to do the same in your work. Please don't make me guess where you put your decimal at. And the decimal is really important, right? If I say you have $47, that's a lot different than if I say you have 47 cents, right? And we know dollars versus percents based off of where the decimal is. So there's a big difference, and that decimal is really important. So make sure as you're writing things, you're clearly showing where that's at. Now, what happens if I don't have a whole number? Let's say I'm dealing with 27.6%. It is literally the same idea. I'm going to take that 27.6, and wherever that decimal is, which is right here, I'm going to move it 1, 2 places to the left so that this thing is equal to 0.276. So the rules are always the same. Wherever the decimal is, move it 2 places to the left. Now, converting from fractions to percents. So this is kind of the idea of now I am going backwards. So I am trying to take a fraction, and I'm then going to put that into its percentage form. So let's say I give you something like 7 over 8. We know that 7 over 8 is the same thing as saying 7 divided by 8. And if you utilize your calculator and do 7 divided by 8, you get 0.875. That decimal form is useful to you because we just talked about the relationship between a decimal and percent. When we started with a percent, we moved the decimal to the left 2 places in order to get its respective decimal form. So now I'm trying to undo that. I'm starting with the decimal form to get to the percent. So in order to get to the respective percent, I'm going to take my decimal place and I'm actually going to move it 2 places to the right so that I get 87.5. And don't forget to write your percent sign. Very, very important, right? You can't just change a number without having purpose as to why you changed it. And our purpose here is to convert it to a percent. So you need that percent sign. Let's do another one. Let's say I had 3 over 4. And again, that's the same thing as saying 3 divided by 4. And that gets us the value 0.75. So if I want to put that in its equivalent percent form, I'm going to move the decimal 1, 2 places to the right, and that gets me 75 as a whole number percent. Okay? Let's really think about something that's probably been a while since you've seen it. This is a different type of fraction that we called a mixed number, 1.5. When I think about 1.5, I can write this. I'm going to actually write the term here. This is a mixed fraction. I can write this as what we call an improper fraction. When I write something as an improper fraction, that means the number on top, which is our numerator, is larger than the number that's on bottom, which is the denominator. I do that by, I'll highlight this here, I'm going to multiply the denominator times the large number, which in this case is 2 times 1. 2 times 1 is 2. And then I'm going to add that value to the numerator, which I'll highlight that in purple for you. So again, to just speak through that, you're going to multiply the denominator times the big number. So I've done that in orange. 2 times 1, which is 2, and then I'm going to add in the numerator in purple, so 2 plus 1 is 3, over the denominator that was already there, so the denominator does not change. So all that multiplying and adding is to help you get the number that is going to be in your numerator, and whatever value is in your denominator stays the same. And if I take 3 divided by 2 and I go ahead and convert that to its decimal form, that actually equals 1.5. And again, if I'm going to convert that to a percent, I'm going to move it 2 places to the right. But do you see what happens? There's no number, right? So in order for me to move it 2 places, I skip over a value that's not there. So I'm going to put what I call a placeholder of 0. And this is equivalent to 150%. All right, so let's look at a word problem. Let's find a certain percent of a whole. Target is running a promotion where you get 20% off your total purchase. If you spend $132, how much money will you save? What will be your total amount that you pay? So the first thing when you're dealing with a word problem is to not get overwhelmed. And we have a tendency a lot of times to get overwhelmed with these sort of problems. So you want to try to stay away from that and identify key information. So some key information is right here, our percentage value, which is 20%. We also want to know how much we spend, which is 132. That's my total amount. Then I want to think about the questions that I'm being asked. How much money will I save? That's its own question. And then the next question is, what will be the total amount that I have to pay on the item? So let's start out by making our little statement. Blank percent of blank is blank. And let's fill in our blanks. We have 20% of our total amount, which is 132, and I'm trying to figure out what is that. So 20 out of 100 is equal to x over 132. And just like before, I'm going to cross multiply. So 132 times 20 gives me 2,640, and the other side gives me 100x. And in order to get x by itself, I'm going to divide by 100 on this side. I'm going to divide by 100 on the other side. And that leaves me with x is equal to 26.4. Now we want to think about, what is that? That is 20% of $132. That means out of $132, if I'm getting 20% off, that is equivalent to $26.40. So that is the answer to how much money will I save. But how much am I actually going to pay? Well, if the original item cost $132, and I'm going to get 20% off, so that is minus $26.40. I'm going to utilize my calculator for that. 132 minus $26.40. I end up only having to pay $105.60 after the sale. And that is my total amount that I pay. Okay? Of 60 runners who started a 5K race, 45 finished the race in under 40 minutes. What percent is that? So let's think about the information we have. Of 60 runners, so that's my total amount, 45 actually finished. And the question being asked is, what percent is that? So when I go to set up my problem, blank percent of blank is blank, and I plug in my particular values, I don't know what my percent is. That's actually what I'm looking for. But my total amount is 60 runners, and I know that 45 of them finish. So this one looks a little different. It's a different blank, but the idea is exactly the same, right? So I'm going to put x over 100 is equal to my is over my of. And I'm still going to cross multiply just like I did before. So I'm going to take 100 and I'm going to multiply that by 45, and that gives me 4,500. I'm going to multiply 60 times x, and that gives me 60x. And then in order to get x by itself, I'm going to divide by 60. So that leaves me with just x, and that means I got to divide the other side by 60 as well. And that gives me 75. So what percent is that? That is my final answer, which is 75%. So it doesn't matter what blank you don't know. You can have, any of them can be the unknown. It's just looking at the values that you're given in your word problem and figuring out which blank they fit into. That's the key. Alrighty. Hopefully this was a good review of what percents are, or hopefully you feel a little stronger in what a percent is and how you can use it. There's going to be some other materials and videos in this week's module, but as always, if you have any questions of anything that I covered in this video, please do not hesitate to reach out, and I hope you have a wonderful rest of your day.